asking the question, what is your value of a minute? My name is Brad Allen from the company NOx LLC. I'm responsible for the Promex measurement solutions in the North American market, representing our partner company Ascona GmbH, based in the south of Germany. I'd like to first thank you for your participation in the Global Aluminium Expo 2023 and hope you will gain some interesting insight over the next 20 minutes. I'd like to start off with a clear view of how we value time in our lives and how the need for time drives progress. Historically, we can see many valuable ways in our personal lives and work lives where tremendous time savings has occurred primarily through innovation. Food gathering. From a time when hunting, gardening, and raising livestock for our daily food provisions, to now being able to stroll the aisles of a grocery store, through many innovations, we gain significant amounts of time. Travel. From a time where crossing the country on horse or in a wagon would take months and longer, to be able to take the family on a road trip and see large portions of the country in only days, or even fly across in hours, we've experienced endless hours of time savings through innovations in travel. And the list goes on. Construction, medicine, communication, warehousing, and so many more. All areas of our lives that innovation has brought time savings, improved quality, and has significantly simplified our lives. But innovation is not free. In many cases, there is a significant cost, but seen throughout history, the value in savings far exceeds the financial investment. Let's look now into a more specific area of where we are spending time and look at the aluminum extrusion process. Specifically, let's look at something that takes time to do in every aluminum extrusion process: profile measurement. Historically, many quality control tasks in aluminum extrusion have been manually intensive. Quality checks directly in the extrusion environment of a plant are even more likely to be done manually, as it's not been possible for elaborate measurement devices to be located in those hot, dusty, dirty areas of the plant. Depending on the complexity of an extrusion, the frequency that the profile dimensions need to be measured, and the data collection process for tracking dimensional results, the amount of time spent on this process is often not recognized, but is definitely costly. The dimensional measurement of an aluminum profile is a critical piece of the quality control process in every extrusion facility. Here is an example of a profile where the measurement requirements are quite clear, but there are some points to consider. First, because the part is symmetrical, the 12 shown measurements will end up being at least 44 dimensions to measure. Next, there are multiple measurements which will require the usage of pin gauges, which is not simple in the extrusion process. Next, there are multiple measurements that will require careful measurement due to small features within the profile. The time spent on measuring this profile and documenting the results would take several minutes at the press with manual measurement devices. Finally, there's known variation from one person to another, which will always happen within manual measurement devices. Now, let's consider what a real-world manual measurement process would look like and compare it to what a measurement solution using the Promex technology would look like. Through innovation, the company Ascona GmbH has developed a profile measurement solution that is designed to be located within the extrusion environment and operated by the people that can most quickly affect change in an out-of-tolerance situation. Below, shows a customer's Promex Expert system being located between two presses. Samples are taken and measured pre-stretch by the press leads and post-stretch by the saw operators. Measurement results are visible and reviewed at each press, saw, and the offices shown below. In a typical manual measurement scenario, press leads would be using gauges or calipers or other devices to manually measure dimensions, but final inspection for dimensional tolerance would be completed by quality, either in the quality assurance lab or by quality tech moving around the plant. Let's complete a small time tracking analysis of an aluminum extruder measuring a profile manually with gauges previously discussed and with a Promex Expert measurement system located directly next to their press. On the left, you can see quality tech using manual gauges to complete the measurement cycle and all the critical dimensions that are required for that profile. As you can see, this is taking him several minutes, but on the right-hand side, you can see the exact same profile being measured within a Promex Expert system, and we'll see the time difference. Through innovation and automation in the measurement process, you can see that the time savings for this extruder on this single profile is 7 minutes and 30 seconds on a single sample. Now that we see there is a clear opportunity for time savings within the typical aluminum extrusion process, let's try to determine what level of value opportunity you may have as an extruder. So the question begging to be asked is, what is the value of a minute? What is our cost of time? What is our cost or value for 7 minutes and 30 seconds? So what is our value of a minute? How much time could we save? Let's be conservative and look at some numbers. In a one extrusion press situation, taking on average 5 samples per hour for dimensional measurement, let's say again conservatively, we're looking at 4 minutes being saved per sample to measure with the Promex technology over manual measurement. The press runs about 20 hours a day, 5 days per week, and let's say we run at 50 weeks per year. In total, that's 100,000 minutes per year. That's 70 days in an 8-hour shift per year. If the prospect of saving 70 days a year for an employee at a single extrusion press would be valuable to you and your process, then the questions are simple. How many presses are in our extrusion process? How many samples are being measured each day? Are we using manual measurement in extrusion? On average, how long does it take to measure? If we could measure faster and more accurately, would there be a benefit? And really, what is the value of a minute in our plant? As we can see, much like all the other examples throughout history, innovation in measurement can once again take us from the old methods of the past to a new future of savings. I'd like to take a moment and highlight one of my customers in North America, actually in Canada, Aluminium, and the benefits and the value that their Promex systems provide for them. Highlighted an example of an article where they said, since some of the hole-to-hole tolerance and fin locations during a production run can be difficult to measure, as you can see highlighted in the images above, AlMag uses the Ascona profile measuring system from Ascona, allowing them to measure the part digitally during extrusion. Quote, "This is a very cool best-in-class measuring system that really helps set us apart and helps with supplying a quality part in a shorter lead time. The digital scans were communicated to our customer throughout the development process." Joe Jackman, President, Aluminium. So how could we help you? With representing partners around the world like NOx LLC in North America, the innovation of the Promex measurement solution from Ascona enables aluminum extruders to achieve valuable time savings within their process. In conclusion, as the old saying goes, time is money, and I'm happy to tell you that the Promex profile measurement solution can save you both. Thank you so much for your time here today, and I hope that I've given you some thoughts to take back to your team and consider what your value of a minute may be and how many minutes can you save. I'll be very happy to address any questions that you may have now live, or look forward to any emails that you may want to send. I'm in close contact with all of the Ascona partners around the world, so even if you are not from North America, please email me any questions and I can put you in contact with the appropriate person in your region of the world. Thank you again and have a wonderful day.
Hello everyone. I, Amit Kumar Gupta, working as a Senior Manager Operations at Smelter Plant NALCO in the Indian state of Orissa, welcomes you all in this session on the presentation on the topic, the challenges and opportunities for implementation of Industry 4.0 solutions at the aluminium smelter plants in India. In this presentation, an attempt has been made to give you a brief overview of the Indian aluminium industry, various perspectives, and the implementation of Industry 4.0 solutions in the smelter plant of Hindalco, Vedant, and Nalco. Although the information whatever has been mentioned has been taken from public domain, or the information gathered through personal interaction with the plant personnel. The presentation outline will be this, starting with the introduction, giving you an overview about Industry 4.0 and aluminium industry, followed by industry analysis, challenges and opportunities, latest development, key learnings, recommendations, and finally the conclusion. Let's have a brief about Industry 4.0. As we all know, there are currently 4 industrial revolutions the world has witnessed, although the talk of Industry 5.0 is in the market, but let's us restrict to Industry 4.0. The first industrial revolution was characterized with mechanization and introduction of steam and water power, followed by Industry 2.0 for mass production assembly lines using electrical power, followed by Industry 3.0 with automated production using computers, IT systems and robots, and the current era which we are witnessing, the smart factories with no or literally very less human interactions for the production processes or services using autonomous system, Internet of Things and machine learning. The various Industry 4.0 technology and techniques involve the cloud computing with cyber security, Internet of Things, which is important for India, what we call for industries, industrial Internet of Things, IIoT, with system integration, simulation, which is very important for production process control and quality management, as well as training, robotics, which are taking robots are taking care of this hazardous activities, and big data, augmented reality, and additive manufacturing. The basic aluminium industry value chain is like extracting ore, which is alumina from bauxite, which is bauxite is a raw, alumina is a raw material for aluminum smelting, which again is an energy-intensive process, followed by casting, whereby we get semi-finished or finished product. The aluminum smelter is basically having 3 sections like carbon area, cast house, and potline. The input for potline is alumina, power from captive power resources, because it is energy intensive and we need continuous power supplies. So with the use of carbonaceous material based green anodes, the electrolytic process is carried on in pot furnaces producing hot metals. It is again sent to cast house for production of semi-finished or finished product as per requirement and marketing demands, and finally goes for dispatch for the purpose of sales. Here are graphs which shows interesting fact, like after only 1885 with the invention of hot alloy electrolysis process, the production of aluminium rose, and after 1920 only the prices started decreasing. Otherwise aluminium was considered as precious as gold, even more precious than that at one point of time. The production of India is packed around 3.5 to 4 million ton, and approximately 5.5% of the world production comes from India right now. With major of the application in India, aluminium is finding major application in the area of electrical appliances or electrical uses, whereas in the western or the other part of the world it is finding more application in the transportation or rather automobile or higher end application. The per capita consumption in India is also very low. It was 2.4 earlier kg, 2.4 kg. Right now it is somewhere around 2.7, again with the world average of 11 kg. It's way far to go to catch up with the world average. The key Industry 4.0 element deployed in aluminium industry are digital process production process and its control, automation and robotics, and most importantly, industrial Internet of Things, whereby you can access information anywhere from any device. A study reveals that implementation of levels in aluminium industry regarding the know-how of Industry 4.0, it is very sorry picture that already deployed Industry 4.0 projects, just 11% is the response. It is very low. But if we look after the functional area, production and R&D with highest percentage of Industry 4.0 application gives a hope, and with distribution, logistic and supply chain catching up the pace. Well, if you go through industry analysis using Porter 5 forces model, we can see although the competitive rivalry among the players is very high, along with the high buyer and suppliers bargaining power, with moderate to high threat of substitutes like steel and composite when it comes to cost. But still there is moderate threat of to new entry. Why? Because with new technology, higher K ports, the economies of scale and automation provides them the opportunity to enter into market. Maybe we might see new players in the market, or the existing player will upgrade for sure. As you can see from this graph, the region or country-wise specific policy on aluminium across the world, almost every part has some sort of national policy on aluminium, but it is surprising that India, although Niti Aayog has documented in the year 2017 itself a policy document for aluminium, but it has not been formally announced by the government. Although government from time to time do something to support our industry, but a formal policy and recognizing aluminium as a core industry will help a lot for this industry. Now, coming to the challenges before aluminium smelter is first and foremost is retrofitting of old smelter who are lower K, operating at lower amperage for enhancing their efficiency and to remain cost competitive. Recruitment policy need to be changes. Training of existing workforce is huge because of the concerns of return on investment. Large scale waste generations like disposal of pot line, dross or TED bulk. Their storage as well as disposal is a huge concern which cannot be done like anything. Implementation automation has its own fear, like industrialization problem, because whenever industry is being set or operate, there is a huge people have huge expectation from that particular project. They want jobs, but with automation jobs will reduce, or rather better and fewer jobs, like in the IT or computers field will be there like before. So locals might find it difficult to get the jobs unless and until they upgrade themselves. Moreover, risk to data security is there if you go to cloud. Many industries are therefore avoiding this cloud, but it is not a good solution because without cloud it is very difficult to catch up with Industry 4.0. The technological disruptions like ELSIS in future which is going on a production on pilot scale. It is a joint venture between Alcoa, Rio Tinto, Alcan, and the Canadian government, and with a minor stake and technical support from Apple. It's based on inert anode, which will change the future course of aluminum industry altogether if commercially proved viable. Now, what are the opportunities for aluminum smelter in this? Better control, process control using automation, reducing human error altogether, thereby improving the system efficiency, digitization of the entire value chain. COVID has taught us that how value chain, supply chain is very important, because it's got entirely disrupted, and even till now we don't have enough of the inventories, and industries are struggling to keep pace with the production process. Integration of all business activity, thereby reducing the friction among the various functions. Remote employee engagement, this is very important. Now, the talent attraction as well as talent retention has become easy because of the remote location of the this sort of manufacturing or process industry. It becomes difficult to retain talent as well as to attract them. Now, what with remote employee engagement as to the level as high as 50% in the COVID era, it has given a new ray of hope to the industry. IIoT as a means of business continuity. You can access anywhere any information from anywhere from any number of devices. Better inventory and waste management will hold the key. These are some of the latest development, like current distribution using Bluetooth. Even the online devices are being implemented there in various smelter, automatic casting of anode, butt cleaning using robots, pit stripping, pit monitoring, and zero level or ground level cleaning using robots, which require the humans to carry on the hazardous activity, have been completely or in many places partially eliminated by the use of robots. Digital twin is a fantastic example. It is simply a computer program which uses real-time data for simulation to precisely predict the performance of the process or the product. It is simply based on the system. You have got a physical asset, you build a digital model of it, give the inputs precisely, you will get the idea what will be the possible outcome. It has immensely benefited in the industry in the way that it has helped in increase of almost 1% of the current efficiency, faster decision making, and moreover the early problem detection and damage control by preventive maintenance, and further with better waste management, and the quality of the finished good has immensely improved in this process. The implementation of various Industry 4.0 at the aluminium in smelters in India. Here is a quick snapshot. Like first, Vedanta is a front runner with its Balco and Vedanta aluminium plant at Jharsuguda. It has implemented digital twin in collaboration with General Electric. It has tied up with various cement manufacturers supplying their waste material, and has a very good chain of managing its waste material recycling processes, full automation of almost all its plants, whereby Hindalco Industry followed different strategy. It's very aggressive for its new smelter, whereas going slow with its old smelter. Few examples include interlocking of PTMs, live interaction between cast house and pot line, which helps in containing the loss of temperature, and automatic robotic scheming, automatic labeling and barcoding, removing the human error altogether. As it is completely done by robots. Dashboards all the way to have a quick access to the information. Nalco started late but pacing up fast with its in-house talent and stable manpower. Since it's a PSU, attrition is low. Compressed air monitoring, online data transmission in carbon area, in cast house, and the system has enabling of digitization of the entire process, which includes recording a hot metal weight, onward transmission of the data, report generation, storage of data. Everything is done using the digital platforms. A digital potline is the latest initiative in the series, which has been introduced 2 years ago, just when the COVID hit the industry. The data shown here is in the visualization format using Power BI and R language. It has been created, and it mines the data from the potline server. We don't have cloud server on the clouds. We have our own servers, so it's not a problem for us. Here is a quick snapshot of the digital potline dashboard, which shows the various process parameter in one go, helping our engineers to take faster decision and rectify the problem at earliest. A study has been conducted, and the types of questions divided into 15 with internal know-how about Industry 4.0, about opinions related to external environment and impact, priority area. Although the concern related to ROI, return on investment, was an issue, but the belief that positive changes are coming in the organization, and more hazardous activities are being executed through the use of robot, avoiding human intervention, was encouraging to implement Industry 4.0 solutions. The key learnings from Vedanta or Hindalco includes availability of contract manpower or cheap manpower is a major deterrent for adoption of automated guided vehicles, which requires huge capital investment. Cost of upskilling is a major cost, but it is still preferred in order to be future ready. Cost leaders such as Vedanta is opting for a third-party consultancy. It is heavily outsourcing its activities and only concentrating on its core activity to be executed by its own employees. Hindalco is following a mixed strategy as already discussed. Central PSU like Nalco has started late but trying to catch up very fast with his in-house talent, and with retirements in more and more retirements coming here, it's going to outsource its non-core activities and will focus on core activities to its regular employees. And with the availability of stable and competent workforce, top management is trying many things, very low investments, including the mobile app development for almost all the activity related to existing employee, retired employee, or you talk about stakeholder management or customer management. Recommendations for smelter plant. Digitization of all the records is must. Outsourcing of all the activities which are not part of core activities. Higher version of user interface with better analytics from technology providers. In workplaces, having repetitive nature of job, automation is must. And human resource utilization should be there only where creativity and critical thinking matters. Waste management must be given attention using prescriptive as well as predictive analytics. And finally, coming to the conclusion, investment in automation would be a right step to reap its benefit in future. New smelter are better positioned to apply Industry 4.0 solution and get benefited, but whatever way possible, old smelter cannot be neglected and should be automated to remain competent and profitable. Due to COVID pandemic, the mining manufacturing industry has got a ray of hope, which never realized that remote working is a possibility in this industry. But as high as 50% of its workforce realized that it's possible with adoption of Industry 4.0 technique. With simple solutions, with simple implementation, there are wonderful outcomes. So, with all this, we come to the end of this presentation. You can reach out to me using the following contact details given here. Thank you for your patience listening.
Hi, my name is François Racine, CEO of AlUquebec. AlUquebec is a nonprofit group promoting the growth of the aluminum value chain in Quebec, in Canada. So the presentation will give you an overview of what we do within Quebec, within the aluminum industry. As I said, AlUquebec's mandate is to support the economic development of the whole value chain, from the production of primary aluminum to the transformation and promotion of aluminum in various markets where aluminum is a key material. So we basically interact with all the players of the value chain. And as I said before, we're a nonprofit group with private and public funding. And our main activities with our center of expertise is also to offer technical support, trainings, work on various standards where we can promote a better use of aluminum in various end markets. We will support some development project, even be involved in the engineering phase of some of those projects. And also, obviously, we will help to connect various key players to strengthen their relationships. Why Quebec and aluminum? Basically, about 75% of the primary aluminum production in North America is done within the province of Quebec in Canada. We produce approximately 2.8 million tons of primary aluminum production. And in fact, we're getting close to about 3 million tons a year of primary aluminum production. With the lowest carbon footprint in the world, basically all the electricity produced in Quebec is made from renewable. Therefore, all the aluminum produced in Quebec is made from renewable energy, mostly hydro, but also wind power. There's about 7,500 employees within the primary aluminum production in Quebec. We're also very much involved, obviously, in the processing and usage of aluminum, transformation of aluminum. There are more than 1,700 companies within Quebec working with aluminum at various degrees. Close to 30,000 direct jobs related to the transformation of aluminum, with an impact of close or more than 1 billion Canadian dollars, which would be about $8 billion US. We also have a network of equipment suppliers that work very closely with the primary aluminum producers, developing equipment and technologies to support the production of primary aluminum, but also in the use of various cast houses related to rolling mills, for example, or extrusion facilities. Those equipment providers are exporting all across the globe and sharing their technologies with various primary aluminum producers all over the world. So basically, AlUquebec act as a basically a networking agent to connect all those key players within our network to work together and obviously to develop new markets within Quebec and obviously outside Quebec. This map shows you an idea of where the various companies are located. You see in red where the primary aluminum production is done, and also where the other players within transformation or equipment suppliers are located. And the map on the right gives you an idea of where is Quebec within Canada. And as I said before, this is where 75% of the North American primary aluminum production is done. What's interesting to know is that Quebec, because of the free trade agreement that Canada has with the US and Mexico, Quebec is well positioned, obviously, to support the development of the North American market with our aluminum expertise and our access to the US market. Canada has also a free trade agreement with Europe, but obviously our commercial relationships with the US are obviously more important. As I said, in terms of primary aluminum production, we have three world-class companies located here. Alouette, which is a joint venture between 5 partners, which include Rio Tinto and Hydro Aluminum. Obviously, Rio Tinto is here and has been in Canada for many years. And Alcoa is also present with the operation of 3 smelters. One thing that is interesting to note is that the first production of aluminum, primary aluminum production, started in 1901. So more than 120 years, we have been making primary aluminum in Quebec. As said before, we also have a strong network of equipment developers and technology developers that are servicing the primary aluminum production. You see some of the names on the right side of the slide, but basically they are involved with the primary aluminum producers and other aluminum transformation facilities where molten aluminum is present. And the companies are developing equipment to basically filter, improve the qualities of the material, and equipment to move around within the facilities, autonomous vehicles, and basically all the type of equipment that the primary aluminum producers would be looking for to support their operations. And as I said before, those companies are exporting and are present in the Middle East, present in Asia and in Europe, and are continuously developing their external markets. We also have a very strong processing sector in various end market, and this slide gives you an idea of some of the markets that are supported by the companies within Quebec. Verbon is a key supplier for Tesla, for example. They support body parts made from warm forming. We also are very much involved in the promotion of the usage of aluminum in various type of infrastructures, including pedestrian bridges and bridges. And AlUquebec support a lot of projects to push further ahead the use of aluminum in this market. We also have companies involved in the use of aluminum in transmission towers, for example, emergency restoration systems, and we're involved in R&D projects to increase the use of aluminum in energy transportation in terms of infrastructures. Other example, we have companies involved in the cladding and basically the external panels for buildings made with aluminum. Heavy machineries are used for transportation, so commercial transportation is also a significant market for us, as is public transportation equipment using aluminum for the structures of those vehicles. We also have a very strong aerospace sector. Montreal is one of the basically three largest aerospace cluster in the world. So obviously a lot of aluminum is transformed and used in our local aerospace sector. And you have here a few names representing some of the key players. Bombardier, who's a private aircraft manufacturer, Sonaca making aircraft wings for various type of aircraft, and Meloche making all sorts of components for the aerospace industry. But obviously, this network is a lot more important than what you can see on the slide. We're also very much involved in R&D, and a lot of the R&D is done obviously locally, but quite often also jointly with other R&D centers located outside Quebec or outside Canada. We're very much open for collaboration. Of the main important center, obviously you have the National Research Council of Canada, who's very much involved in various steps of aluminum transformation and supporting development of new applications in various end markets, but mostly automotive. We also have the Quebec Metallurgical Center, which is also very much involved in the development of new processes, and also in the support of the design of parts made from various aluminum transformation processes. We also have what is called the REGAL, which is basically a network of all the universities located in Quebec that are involved in aluminum R&D, whether it's related to the production of primary aluminum or transformation of aluminum end market, or ancillary processes that are related to the usage or transformation of aluminum. This is a strong network which basically supports the networking within the universities to work in collaboration with each other instead of working in isolated silos. And over the years, it's been in action for close to 20 years, has created a lot of papers that have been published on a global basis and are really showing the quality and the level of knowledge related to the aluminum industry that we have locally. As you can see, in terms of R&D teams, it covers everything. More and more, we get involved in digital transformation, which is becoming more and more important in terms of automation to make the workplace more secure, but also more productive. Work related to the improvement of the environmental impact of our industry. Obviously, recycling is part of that, but it's a lot more than this. And other manufacturing processes to help basically make aluminum more competitive with other materials. As you can see here, an example of some of the facilities or type of products that are being developed where aluminum is is used. And again, we have a very strong network of R&D centers that are open to obviously collaborate with other centers across the world. And we believe we have really world-class facilities and world-class knowledge that will help us make strong improvement in terms of the promotion of aluminum in new applications. On top of that, two of the largest private producers in the globe, also have R&D facilities within Quebec, and we're very, very proud to be the host of those facilities. Rio Tinto have their World R&D Center for Aluminum located here in Quebec, and the World Excellence Center for Smelting Technologies of Alcoa is also located here in Quebec at their Deschambault smelter. Within AlUquebec, to support the use of aluminum in various end markets, we have created working groups. One is involved in the use of aluminum in construction, more specifically sustainable construction, where the qualities and durability of aluminum are moved forward. Infrastructure and bridges, which is a little bit less common across the globe, and we think we're at the forefront of the development of new technologies and development of products in that field, working very hard with the public officials or public entities that are most of the time the purchaser of infrastructures, and obviously we're making or showing the advantage of aluminum in terms of durability, in terms of total cost of ownership, and we'll talk a little bit more about that later on. And again, we have another group dedicated to transportation equipment, a group to create a stronger network within the equipment and specialized suppliers, and also support them in their international market development. We have another working group focusing on recycling to improve the recycling rates and also improve the quality of the recycling being done and make sure we get the best value out of the secondary aluminum that is produced locally or that could be processed here locally. The last working group is a group which is focusing on looking at the mid to long term impact of our industry, and it is really focusing on how we can make sure that our industry will be a world-class supplier, will maintain a leadership position, and will continuously improve itself to make it more sustainable in terms of responsible production, in terms of environmental impact, and obviously in terms of new applications. Within our website, we have a lot of directories. A lot of them are in French, as French is the main language in Quebec, but some of them are also in English. But most of them, anyways, have a lot of pictures, and a picture says 1,000 words. But basically, we have directories for the various distributors of product in Quebec, and also those dedicated to the building and construction sector. Another directory which showcases what we've done in terms of construction locally. Another dedicated to infrastructures, so pedestrian bridges and bridges done with aluminum. Directories of our equipment and specialized suppliers. So obviously, you're more than welcome to go and browse and see what we've been doing with aluminum here in Quebec. Key factor for us in terms of sustainability of our industry, obviously, is to support the continuous improvement of the industry in its ESG standards and ESG behavior. So in pretty much everything that we do, I mean, we always have the ESG factor in the back of our mind, making sure that we improve the environmental impact of our industry. And obviously, in terms of social policies and governance, I mean, we have the best practices in place, and always supporting our companies to improve themselves in that regard and be world-class leaders in terms of ESG practices. To support and promote the use of aluminum, and as we said, with the environmental factor more and more critical in the decision process of the purchaser. We've done some work to compare the impact of aluminum with other materials like steel, for example, in terms of life cycle analysis, but also total cost of ownership, to show that aluminum is really a durable, sustainable product. And often the use of aluminum in infrastructure, for example, is the best decision. Quite often, the initial purchasing cost of aluminum will be a little bit higher than steel when we look at an infrastructure. But if we look at the total cost of ownership, when you factor in maintenance, repair, and replacement in some cases, if you look, for example, at a 75-year span for infrastructure, in all the various types of infrastructure that we've looked at, aluminum was always cheaper, and this is the sales pitch that we're basically using to support the use of aluminum in public infrastructures. Same thing in terms of life cycle analysis, as more and more project promoters are concerned with the environmental impact of the project they're doing. We've done life cycle analysis comparison. In that case, obviously, I mean, the assumptions that you're making are very critical. So it's not always, the results are not always as shown here, but in our assumptions, obviously, a big portion of the aluminum used is one produced here with renewable energy, which is the case really within Quebec. There's also some secondary aluminum which is used, and when whatever is needed is not available locally, we make the assumption that the product is coming from North America with a North American carbon footprint or environmental footprint. Regardless, in most cases, the environmental impact of aluminum versus steel, which is also sourced locally, is more or less the same, and most of the time a little bit better for aluminum. So all this to say that, for example, in the case of aluminum infrastructures done here in the Northeast in Quebec, we have a very competitive environmental impact, but a much lower total cost of ownership, which makes the decision of using aluminum obviously critical and quite often the best decision. Obviously, to support the use of aluminum in various applications, we need to make sure that when standards need to be applied, obviously, we need to make sure that aluminum is considered and is included in those standards. And representative of AlCircle and other representative of the aluminum industry are quite active in various working groups, for example, for the Canadian Standards Association, which is often the standards that are dictating how and when a material can be used. So obviously, we're very much present in those working groups. Finally, we're also quite involved in developing technical papers and trainings to support the knowledge of the usage of aluminum for engineers, for architects, industrial designers. So we have designed internally and with external experts quite a wide range of tools for training and to support the usage of aluminum and the training of future students or future architects and engineers to make sure that they are comfortable using aluminum. We have a bunch of manuals and training material which is available from our website to support, again, a better knowledge of aluminum for future and current professionals working with aluminum. We're also promoting the use of aluminum for university students, and each year we have a competition which basically regroup mixed teams that are made of our future architects, engineers, and industrial designers. And every year they work on a specific project, and they're competing within each other to come up after 4 days with the best, basically the best design. And it's a growing contest, gaining in popularity. We have more and more companies wanting to be associated with the project, and obviously more and more students each year are involved in this challenge. And it's a nice way to promote aluminum within the various engineering and architectural schools located here in Quebec. Next challenge, next September. It's always the second week of the beginning of the classes in the fall for us. And obviously, we're looking forward to meet new students who will be competing. And already many months from the challenge itself, I mean, pretty much all the available places have been taken by students who are eager to get involved. So it's obviously quite positive for us to see that kind of enthusiasm for this challenge. And finally, 2023 is a super year for us in terms of international exposure. 2 international conferences will be taking place here in Quebec. One next May, mid-May, Future Aluminum Forum, which will mostly focus on sustainability, but also what we would call Aluminum 4.0. So everything that will automate the industry and make sure that we use artificial intelligence and all the technologies to really rely on the new high-tech possibilities to make our industry more productive and more secure. And finally, next October, AlCircle will also be in Quebec City, mid-October. And this conference will focus on various end markets and application and transformation technologies for aluminum, mostly related to transportation and infrastructures, but basically a nice showcase of various processing improvement that have been done over the years. So obviously everybody is welcome to come and attend those conferences. So again, I thank you very much and looking forward to answer your questions if you have any. Hopefully, we will see you in Quebec sometimes. Thank you very much.
Unplanned downtime costs the global economy more than $100 billion annually. More than 50% of downtime in the industry can be attributed to equipment or structural failure. On top of this, with limited on-site personnel, maintaining a thorough oversight of the health of rotating equipment remotely has never been more important. The downtime due to rotating equipment failures can now be completely avoided with predictive and prescriptive maintenance system called Rotation LF that comprises of an IoT-based hardware and an AI-powered platform invented by NanoPrecise SciCorp. This completely automated solution consists of 4 basic steps. This unique hardware can measure triaxial vibration, acoustic, temperature, RPM, magnetic flux, and humidity from one single sensor, giving a holistic view into the health of rotating equipment such as fans, pumps, motors, compressors, and blowers. It can detect both mechanical and electrical faults. The sensor can be stud-mounted, adhesive-mounted, or magnet-mounted. Once mounted, as soon as it is switched on, the sensor will be automatically connected to the internet as through standard cellular Wi-Fi or enterprise Wi-Fi. Once connected, data processing happens first at the sensor edge, where acoustic emission and temperature data are used to detect any anomalies. Once the anomaly is detected, data is sent to cloud for full analysis. On the cloud, highly sophisticated signal processing algorithms such as EEMD are used to correlate RPM with vibration data to diagnose different machinery-related fault modes. Subsequent to this, highly sophisticated machine learning algorithms are used to predict the remaining time to failure of the asset. The summary of all this is available on a dashboard that can be accessed through an app available on mobile, tablet, or desktop. With NanoPrecise's Machine Doctor and Rotation LF, you'll have full visibility into the health of your machines. With algorithms that are more than 99% accurate, you can avoid unplanned maintenance and maximize the productivity.
Hi everyone, welcome to Global Aluminium Expo 2023, and I am Abhimanyu Prakash, CEO at AlCircle, an organization which has been working for the past decade to try and bring to you new digital solutions for our physical aluminium industry.